A 12 kilogram point mass on a massless stick. All right, welcome to physics. All right, so there's our mass, right? It's like a stick. All right, there it is. So this is radius is 0.42 meters. That's 12 kilograms. Has a tangential velocity of 2 meters per second. How fast is it going if it moves into a distance of 2 centimeters? I guess what we're going to do is we have its radius, its velocity. Let's find its initial. Omega 1 is just v over r. This is a tangential relationship. Comes from v is omega r. Right? That's in the data packet. So let's see. 2.0 over 0.42. 2 divided by 0.42 is 4.762 roughly. Radians per second. It's actually 4.7619, blah, 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 blah. Okay, so that's our initial one. And our initial moment of inertia is mr squared. So 12 times 0.42 squared. Is 2.1168 kilogram meters squared, right? All right. And then let's figure out the I2. I2 is going to be mr squared. So that's 12 times 0.02 squared. Because that's the new one. It moves into that distance, right? And this is just the mass on a stick formula, right? 12 times 0.02 squared. That's small. 0.0048. There's going to be something dramatic here. All right. Okay, how fast is it going? Oh, I'm noticing that the answer is in radians per second, so we're gonna get an answer in radians per second. I'm curious about its linear velocity too, so let's figure that out. The linear velocity will be faster because we will have done work to bring it in, right? To bring it into this distance, we'll have done work, and so therefore it has to gain just kinetic energy in general, right? Okay, so I1 omega 1 is equal to I2 omega 2. So I1 is 2.1168, omega 1 is 4.762, right, from here, right? And then that equals I2, which is 0.0048 times omega 2. So let's figure this out. So 2.1168, boom, times 4.762. Okay, I'm just using the numbers from my calculator. Divided by 0.0048. And indeed, that is exactly 2100. That is crazy. Is exactly 2100. There's some things that science cannot explain. There's got to be some numerical reason here. Oh, it must be tangential relationships. Yeah. Okay, anyway, I'm distracted. Okay, so exactly 2100 radians per second. Now, the velocity is going to be omega r. So it's going to be 2100 radians per second times 0.02, 42 meters per second. Okay, I'm struck by this, right? There's a 42 right there. Isn't that interesting? I'm just not smart enough to figure it out. Okay, so what does that mean? That means that we move it in 21 times. I don't know. I'm going to leave it for my talented and gifted students to figure this out. But it's going considerably faster. I would not want to touch that thing. That's more than 90 miles per hour. All right.